In this lecture, we will find displacement of particle in simple harmonic motion. Sometimes we get the displacement of particle in simple harmonic motion in terms of sine of x, and sometimes we get in terms of cos of x. Now to get both type of solutions, we have equation of motion for a simple harmonic motion, and that is x double dot plus omega square x equals 0. Now we can write second time derivative of displacement like x double dot equals second derivative of x with respect to t equals d over dt into dx over dt. Now if we multiply and divide the numerator and denominator by dx, then we get x double dot equals dx over dt into d over dx into dx over dt. As we know, the derivative of x with respect to t is nothing but velocity. So we can update this equation now. X double dot equals v into dv over dx. Because derivative of v square over 2 is nothing but v into dv over dx. Hence, x double dot equals v dv divided by dx. We can replace now by d over dx into v square over 2. So it means this equation now becomes like x double dot equals d over dx into v square over 2. Now, our equation of motion is x double dot plus omega square x equals 0. Well, update like d over dx into v square over 2 plus omega square x equals 0. We simply replace x double dot by this term. And as you can see in this equation now, which further can be simplified like d over dx into v square over 2 plus omega square x square over 2 into, equals 0. Now we have finally this term, which further can be written like d into v square plus omega square x square equals 0. Now by integrating, we get v square plus omega square x square equals c1. So by integration, we get constant over here. Now by applying the boundary conditions, as we know that at two extreme position where the magnitude of the displacement is maximum, so at that place the velocity is 0. Hence, by putting v over here, v equals 0 in this equation, we get c1 equals omega square a square. Now by putting c1 in this equation, we get, and rearranging the few terms, we get v square equals omega square into a square minus x square, which further can be written like v equals plus minus omega a square minus x square under root. Now you see we have two roots, one with plus, another is with minus sign. First, for the positive root, if we get the plus omega into a square minus x square under root, we can write this equation like dx over a square minus x square under root equals omega dt. And from the trigonometry, we know this is nothing but sine inverse of x over a, which equals further omega t plus phi, where phi is nothing but constant of integration. So we get x equals a sine of omega t plus phi. This is the first solution in terms of sine. Now if we solve the same equation again for the negative root, now we get dx over a square minus x square under root with minus sign equals omega dt. And by using the trigonometric identity, this is nothing but equals to cos inverse x over a. So this is how we can write x equals a cos of omega t plus phi.